Hi there, nice to see someone from Halifax. Very good. Okay, I think we're doing okay, so we'll get started. Hello and welcome to the Coralogix webinar. Today we're going to talk about a pretty cross-cutting problem, production debugging and logging. So this is everything from troubleshooting your existing software, setting up alerts in a sensible way, and much more that we'll get into. So next slide, please. Do some brief introductions. Ariel, how about you get us started with an introduction?
Yes. Hey, Chris. I'm Ariel, co-founder and CEO at Coralogix.
Hello, Ariel. I am Chris. I am a senior cloud engineer, primarily interested in sort of observability technology and almost everything else as it happens. So what are we going to talk about today? So on the next slide.
Yeah, so we have a pretty full agenda that goes all the way from the very foundations of logging and monitoring, formats that we want to stick to in order to be more efficient and have better ways for visualizing and alerting. How do we define severity? It seems easy, but it's pretty tricky. A bit about the best practices that we've seen with over 1,000 companies. So we were fortunate or not fortunate to see so many different logs from so many different companies, domains, and spaces in the past few years that we've learned that there are a few best practices that companies that stick to achieve better results and are generally closing faster feedback loops with their data. We'll talk a bit about alerts that I think are, not getting the right spot for logs. I think a lot of alerting is currently relying on matrix and traces, while logs can be your best friend for log alerts and proactive monitoring. CICD, of course, which is an area that many times we see logs as a byproduct of the CICD process, but it can be actually an accelerator to it. And how we tie up logs and matrix. I guess, Chris, you probably have a few areas that are more interesting to you and that you'd want me to point out.
Yeah, for sure. So I think there are a few key things that I've picked up over the years that were sort of key learning points for me. One was the whole just general idea of structured events in logs. Another was the logging best practices just generally. I feel like those are things that we've picked up over the years, but distilling them into a really consumable piece of information would be brilliant. The benchmark versions is really what sort of gets my eyebrows raising. Really cool. I think it's one thing worth pointing out with the format of this webinar. We've seen other webinars that deliver this kinds of content, and it's very, very theoretical. So, you kind of just talk at a high level about what's amazing and what's great and never actually demonstrate anything. So we're going to be jumping in and out of the Coralogix UI to give a concrete example of how these best practices look. And hopefully this will give you some inspiration and some ideas of what the Coralogix UI can do, but also exactly how these best practices look. And that'll give you a nice foundation to build your own tooling or to take some of those lessons away to your own infrastructure as well. So I'm ready to get started. Ariel, what about yourself?
I'm ready. So let's jump here and start by, by the way, there's a nice bonus to the ones of you that stick to the end. It's why are logs called logs? I don't know if you ever had the chance to think about this, but there's a pretty interesting answer to this. A bit about the format. So we've seen that customers that structure their data, and it's a bit of a hassle to structure data, different ways to do that, but we've seen constantly the customers that take the time to structure data as JSON, which kind of taken over. There's been XML in the past and other formats, but people that do that tend to spend less time on the system, investigate things faster, and achieve better results and better satisfaction of their systems in general and their logging systems in particular. A few reasons to that is super easy to filter. So I'll give a quick example. If I have my logs as JSON, and I see a field that is interesting to me, all that I need to do in order to filter by that field is just filter by, and then it adds that filter and filters by that field. You don't even have to add that text or any type of conditioning. Now, I'm showing that in the Coralogix UI, but this will work. This is nothing too special. This will work in any proper logging UI, including the main ones like Kibana, or if you use Grafana or other open source tools for logging and monitoring. It's easy to visualize. So because the data is labeled by types, when you looked at JSON structured logs, it's pretty easy to come to any of them and just click show graph. So let's say I have an agent name and I just want to show the graph of that agent name, or I have an activity ID and I want to show graph for that activity ID. These things are pretty easy to do. And think about what you need to go through when you want to visualize anything today on unstructured data, and the work that you need to do or create that query to parse that data and then put it on dashboard. So once you have the data ready, and instead of doing that in the query itself, like some of the older fashioned tools in our space, if you do that at the entry level of the data, you achieve faster results for good. So it's not just that it's easier, it's also much faster, and it's also much more friendly to many different users inside the organization. Instead of having just engineers that understand syntax writing it, being able for everyone to use this from a simple UI makes logs a core component for your organization quality, and logs being a very good source of truth. When people start relying on them and relying on the data that they produce and being able to use that data without feeling stupid, that tends to really boost productivity within the organization. Another point is that they're easy to read, and I have a quick example here just to show you what I mean by that. So if there are two logs and I want to write a query to find them, and I just try to do grep on 29, just a very naive example, of course, but if I just try to run grep, I'll get both Ariel on the age and Lior on the date because 29 appears in both. While in JSON logs or structured logs in general, I have different labels. So I can just say age is something, or date is something, or contains something. And then I only find the labels that I want, which means I'm faster and I'm more accurate, because here with two logs, it's easy to see that we got a wrong answer, but when you run on large data sets, you can just get wrong numbers and be affected by it. So definitely another good reason to do that. And it's supported by most coding languages and loggers today. When you look at Log4net or Logback or Winston or Bunyan, but of course, even if you don't do that in your logger or write your logs like that, there are different ways to achieve that. So for instance, in the Coralogix UI, we have our in-app parser. When you go to settings and you go to rules, you have many different ways to extract, parse data just by using standard regex and create like pipelines with conditions between them. There are also ways to do that with most open source collectors. So for instance, with Logstash to create Grock filters. Chris, you want to give a quick overview of how you do that?
Yeah, so Logstash obviously supports a configuration file. And this Grock filter is a really nice example of some of the built-in functionality that you get. This is something you should look out for when you're looking to parse some of your logs. So what you can see here, for example, is that this Grock filter will match on the field message, and it will look for the field client and pass it as an IP address. Now you notice there's no regex for IP there, and there's no regex for number. There's simply a capital IP, capital number. That's because these things regularly come up all the time, and so Logstash bakes these patterns in there for you. So it's just a nice little showcase of some of the things you can do there. Parsing out these messages isn't something that you do to every single time. You don't reinvent the wheel constantly. Always look for those opportunities to leverage the tool set that you've got. So it's just a nice little example. There's another point here, I think, about the whole structured versus unstructured thing. When I was first introduced to this, my gut feeling was, okay, so yeah, I certainly see the value of having structured events in JSON, but I really like these verbose, like prose, like actual like sentences that are like, I am currently trying to do this and it's failing for this reason, and somebody pointed out to me, and it was a very dumb moment for me, but someone pointed out, yeah, you can kind of have a message field as well if you really want. So with JSON, you don't really lose anything. It's completely the best of both worlds. You can have unstructured fields that you don't really analyze. They're just there for humans to read if you really want. And yeah, so you just keep that in mind. The JSON structure you don't lose a single thing with that. You just gain a great deal of the things that Ariel's already talked about.
That connects, by the way, really well to the best practices section. So we'll get to that. I think that structured logs have a lot of different advantages. We'll see them as we move on in this presentation. And it's pretty nice that now we're taking you through the journey. So we started sending logs. They were unstructured. We structured them in some sort of way because we trust Ariel that structured logs are better. And now the next step would be to label them with the right severity. And this seems like a trivial thing. And, severity has existed in logs since they started with computers, but we see that in and out. We see many customers classify their logs improperly, which causes the severity, which is the most highest level of labeling your data to become inactive, and you can't really use it. So instead of looking at billions of logs, you can immediately split them to 5 different priorities of what you want to analyze. And of course, there are fewer logs at the highest severities. So it can really narrow down the data that you need to mess with. And we gave some examples here just to make sure that you know exactly what we mean by the right severity. So debug or verbose logs, we tend to put them under the same bucket. They're there to describe background processes that happen, and you just need them in case something breaks. If you want to understand the atmosphere in your software or in your environment when that happens. So for instance, number of messages in user creation queue is 3,482. Number of queries currently running on your Elastic cluster is this and that. Number of messages in Kafka is 1,000. Or, DB table size is 100,000 rows. Let's imagine this log. So this will be debug. We do write them to the system. We can talk later about our approach in Coralogix and not having to store them, but still analyze them and get statistics. But in general, this is what I would do. And then info logs are easier to understand. Info logs, they represent transactions that are completed. So here we say money transaction, but we're talking about software transactions. That can be user created successfully, money transaction completed successfully, product purchased successfully, user added friend successfully. Any type of full transaction that your code completed would be described in an info log. Then warning logs will be things that didn't go too well in the transaction, but did not affect the completion of the transaction. So for instance, received illegal character for username James, ignoring character. These you still want to monitor, of course, because they can create performance issues sometimes. They can infer usability issues or UX issues. So you want to note that if you ignored a character, or you had to round a number, or you received a float but you only receive integers, so you ignore that, that might affect your customer experience at the end. If you insert a float number and then you kind of rounded it and he sees different numbers or different summaries, but it does not affect the flow of your software. So we keep it a warning and we want to track it. Typically what we want to track: statistics, alerts if it happens too much, alerts if the ratio of that is too high, dashboards that show us the label of how many times these warnings happen for different parts of our software, for different users, maybe for different geographies. Maybe it's a cultural thing and how people use the system. So that's warning. Error, it's easy to remember. Error is the opposite of info. Error is a failed transaction. It doesn't mean that you need to stop everything and fix it, but it's a failed transaction. Someone failed to transfer money, someone failed to sign up, someone failed to execute a query. So this will be something that we will track on a quantitative level. Let me know if there are more than 1,000 errors. Let me know if there are more than the usual errors. Let me know if the ratio of errors for completion of a specific transaction is higher than a certain percentage, and so on. Let me know if more than 100 different users experience an error. We'll talk more about alerts later, but this is the reason we have them. And then, think about yourself investigating an issue. You would search query execution, and you'll see a lot of info logs saying that the query was completed successfully. And then you'll filter only for debug and error logs. You'll find the execution of query had failed at a certain point of time. You query around it, and then you see some debug logs saying that query queue is full, no more queries will be received. And then someone ran a query, and then you see the error saying that we failed to execute it. Now you have the full story. Maybe you need to increase your capacity. Maybe there's some sort of a limitation that you need to apply so the query queue doesn't fill up. So this is basically the opposite of info. And then critical and fatal, this is something that needs to be used very, very carefully, because these are logs that when you see them, you need to probably stop everything and handle it. So no connection to DB, failed to write message to Redis, Kafka broker unavailable, things that when you see them, you define probably an immediate alert on them. And when you see them, you stop everything and it goes straight to your page duty and you handle it. So this is how we structure severities. Now think about this. It helps you triage, it helps you search faster, it helps you isolate issues faster, and it also creates a common language. What I typically recommend is make a screenshot of that right now and put it on your wall. And, now everybody work remotely, but once you go back to the office, put it on the wall and say, whenever you write code and you add logs, look at this and add them according to this standard. Once you standardize severity and someone calls from support and says, I see a critical log, you immediately know to address it. If he says, I see an error log under this class or this category of code or this file name, you already know what that means and what exactly failed. And then you can ask for particular debug logs that are related to that area and so on and so forth. You can imagine how this increases your productivity, creates common language, fastens the feedback loop, and of course shortens MTTR and MTTD. Chris, anything you want to add there?
Definitely. So one of the things that's going to happen is hopefully you'll come away from this webinar and you'll be thinking, okay, so my debug and verbose logs, my info logs, they're a little sparse. We don't have, I think that great phrase you used there, Ario, was the atmosphere of the code, right? It happens so often where you see an error and it's like error occurred, unknown error. And you're like, okay, yeah, brilliant. And then you look for debug logs and you haven't got any. The reason why people don't write many debug logs commonly is because it muddies the logic, right? You end up with, you've got a 3-line algorithm, but you've got 8 lines of logs in there because there's loads of different things going on. People don't like that. One of the tricks that I picked up annoyingly later on, in Java, they call it the map diagnostic context, where you add log lines that will just, that are values or whatever you want, that will just appear no matter what. So as soon as a transaction starts and you're in that thread, a bunch of logs get written and you don't have to expressly declare them in your code. You also don't have to expressly pass the values into them. You can just say the transaction ID or the session ID, the username, the source IP address, that kind of thing. They just automatically appear in the log lines to solve the problem once in the code base and not everywhere in the code base all the way down. It's a really nice way of getting very, very consistent logs. So that's what Ariel said, that consistent language, but also keep your algorithms nice and tidy, keep your code nice and clean and not muddied with all that extra logs. And the problem tends to solve itself for error and critical logs, because 9 times out of 10, you don't have too many of those, that it muddies the waters, as it were, with the code. So it's just something to keep in mind, that as you add more debug / verbose logs, you will find that problem will arise, and the map diagnostic context is a really nice way of solving that.
Cool. And yeah, I definitely agree. Just keep in mind that Java state creates a lot of data, lot of data. Use it wisely. If you're using a certain tool specifically, use it wisely so it doesn't explore your quota. Okay, logging best practices. This is one slide, but it has a lot of information in it. Would love to hear your opinion on these things, Chris, and from your experience. So a few key things that we distilled from our experience that make logging and monitoring in general successful. One is to log communication between components. This is one thing that so many companies do wrong. So they write incredible internal logging. The service that does the queries is perfectly logged. The service that does the alerts is perfectly logged. The service that does the streaming is perfectly logged, and the process that does the payments is perfectly logged. But everything is interconnected these days, and you gotta log the communication between them. And there's a lot of buzz around tracing. Tracing is good, but this is so much better than just the tracing because it tells you the entire story. So, for instance, I would write something like pulling message from Kafka at pulling this bulk size, and then you have all the internal logs, processing, doing this, doing that. This is something that everyone do well. And then writing bulk back to Kafka. This is the amount of messages that I've written. This is the response that I got. This changes everything because now your way to triage if something went wrong, if there's a missing message, where did it go wrong, how long did it take, and what response you got is just in a matter of seconds. Unlike other tools where, you know, two teams say everything works, my logs look great, and when there's no communication log between components, you're missing out on the story, and tracing can relieve that to some extent, but it'll still miss the full picture because many times logs, being free text, can allow you to write an actual story that machine data doesn't produce. Chris, anything there?
I just think that free text idea is the golden kind of piece there. So when you're communicating between components, there are a great deal of different states that thread can be in, right? And it's very, very difficult to capture all of those states with just either Boolean values or numerical metrics, you know, because it could be in some unknown state, something really peculiar, something really bizarre. If you've got a data format that's flexible enough that you can just dump a whole object into it and say, look, the state's in here somewhere, something weird's happening. And that's what logs give you, right? They give you that nice clean slate that you can put whatever you want on rather than being constrained by the framework of metrics. And that's a really, really powerful sort of message there. I think the other thing is just, if you're running microservices, like 9 times out of 10, I would say all of the tests, it's really, really easy to test internal components. And so the errors that you see don't tend to happen to the internal logic of the components. It tends to be these bizarre network issues, these things that happen in your production environment that's just almost impossible to replicate. Those are usually the things that go wrong in companies with mature testing strategies. And so that logging of the communication between components is really the good stuff, especially when those components are third parties, right? Because those third parties might suddenly stop accepting post bodies of a certain size. And if your logs say, I'm posting a 64 kilobyte thing and it works, but 128 kilobytes drops, you know something's going on there. And that kind of visibility into what would otherwise be a black box is super, super powerful. So yeah, I completely agree. Basically
handshakes of everything. Mm-hmm. I've sent that, I've received that. Many times, by the way, you'd see someone saying, I've sent that, and the other one received something else. This is exactly the example you just described. And these things tend to be very hard to isolate. Yep. Another, a continuation to the first point is communication with external APIs. So a great example from Coralogix, we send about 100,000 different emails every month on alerts that our customers define. So think about over 1,200 customers, many users inside each customers, many alerts defined per account. We send a huge amount of alerts, and customers rely on these alerts. Because if there's something critical happening in my system, I got to have it delivered. So we use an email delivery system called SendGrid. Now, one of the things that we've learned that we need to add is the communication that we have with SendGrid, which means I have sent SendGrid the following JSON in order to post it as an email to customer with this email address, and this is the payload that I've sent. And sometimes the customer would say, hey, you escaped my JSON. And we look at the payload that we sent and we say we did not is SendGrid, and we can talk to them. Or maybe we did not send something at all, and we can check and say, hey, we sent it to SendGrid. Let's go to SendGrid, and they have their own dashboard, for instance, and say, hey, it got stuck in your junk, in your spam, or your email server returned an error. So there's this full story again that we want to describe. So we want the handshake. This is what I've sent. This is exactly the payload. Don't be cheap on size of logs. This is I know that. Years ago, when I was in the Army, it was like 2007, 2010. And when we started coding, it was like write very short logs because they create overhead, and you don't want to write big text because that takes your disk and that makes your software slow. In 2020, with the power of compute and the ease of compute, and unfortunately, how over provisioned all companies are in cloud, it pays off writing big logs with all the relevant data that you need, full payloads, and we'll talk now about metadata and other stuff. But don't be cheap on log sizes. Log everything and any communication you have with SendGrid is one example. Of course, Stripe is a great example for an API. You want to write everything about webhooks that you're sending. You want to write everything about them, and so on and so forth.
Just to add on to that, yep. If you're worried about the cost of the logs, compare that against the cost of an outage, and think of the potential cost of an outage. 9 times out of 10, your logs just fade into the background in terms of cost, and the outage is the really big thing. The sooner you can solve the outage, 9 times out of 10, the more cost efficient you are.
I see we have a question, Chris.
Yes, we do. Yeah. Yes, it's just a question about whether the recording will indeed be made available. It'll be on YouTube, and an email will go out after this webinar as well.
So next point is to add valuable metadata to your logs. There are 2 sides to that, but the idea is, and it goes back. So you probably notice everything is coming together. We get logs, we parse them, we give them the right severity, we log communication between components and external APIs. And now what do you add to that? So when I log communication to Stripe, I will add all the relevant metadata that's possible, all the different labels. What's great about logs, they're endless with labels. JSON log is a set of labels around the text message. So I would write a text message saying, sending charge command to Stripe, and then let's add metadata. Time, user ID, the machine that sent it, maybe even, and let's talk about that on the 5th point, but maybe even metric fields around it to give me like a quick snapshot of performance at that time frame. But any relevant metadata that helps you, I would even add something like deal over $1,000. That makes your monitoring and your observability so much better to be able to, let's say you get a PagerDuty because it's a critical log, sent a charge log to Stripe and got a 502 or a 500. Now, if the metadata you add is charging over $1,000, that means someone needs to take this seriously. If the charging was $5, maybe it's a different, priority. The things have, many times there are a lot of things to do, and prioritizing it is based on the metadata that you add to your logs. So we've constantly seen descriptive logs that have relevant metadata that allows me to pivot and understand what happens and get a full picture are always more useful. And that goes straight to the next point. Remember, you're not the only one reading the logs. And we've ran into, when giving training sessions to existing customers, you run into logs like, if you see this log, contact John. Logs that are useless to 99.9% of the company. If there are 1,000 people, it's just John. So write logs knowing that you're not going to be the only one reading them. Leave the extreme example. A lot of the times you're not going to be the one maintaining the system that you're creating. Sometimes it'll even be like an external NOC or an SRE team that needs to get handovered and monitor it. Make sure that if you read it as as an external viewer, you understand what that log means. It's well structured. Its severity is correct. It logs all the different communications between different components and external APIs, and it has all the relevant metadata that you need. And then, of course, if you combine even metric fields to give a snapshot of what's happening on the operating system level at that point, like if there's an error and I see a field that says CPU at this moment, memory at this moment, threads at this moment, and I see numbers there, I can really understand how infrastructure affected my application and vice versa. So now we have structured, well-defined logs that give us a full story, including some of the business insight with the metadata that I filled in to prioritize them. And I get a snapshot of what's happening on my infrastructure / network layer. Think about this single log that I get now on a failure in Stripe or SendGrid or other components or internal components, and how useful that is compared to watching a graph in Grafana go off on Matrix alone. So that's how we look at logs, and once they're properly written, that's how powerful they get. Chris?
Yeah, I just think that information density that you get with the logs is really is the gold there. Just to add on as well, this point about the ease of storage. Keep in mind that there is an infrastructure burden that sits beneath your logging stack, right? So if you decide to run your own logging solution, just keep in mind that knowledge about how to have a horizontally scaling or a vertically scaling stack is super important, right? Because the storage is available for you to purchase, but it's not there out of the box 9 times out of 10, especially with hard disk space. Compute and RAM will be able to scale horizontally very, very easily. So just have a think when you're implementing these things about the underlying infrastructure and how you're going to scale that hard disk space and what that looks like. Or you could do the other options of various different managed services and SaaS providers that will offer a similar or better service, and you don't have to worry about the underlying implementation. It's just something to consider.
That's a great point. Alerts. So let's start with, why do you need log data alerts? Because often I hear companies saying, no, we do everything from Matrix and we have Prometheus forwarders and all. Matrix are great. We support Matrix and Coralogix and work very hard to support them because we think they're great and important, but you got to have the full picture to really have observability into what's happening. And log data, being the first encounter of your code with reality and the best, most extensive source of truth in your organization, will many times be a leading indicator for a problem a lot before you see infrastructure metrics go off or even a business logic matrix. So we like log alerts because they can help us become more proactive than anything else. And it's all dependent on how well you define them. So alerts need to be defined, and this is a mistake that we're seeing over and over with many customers, need to be very, very specifically defined. That means we see some alerts that say, if you get more than 1,000 error logs, no matter what, in 10 minutes, send an email to the general operations channel in Slack. This is exactly the reason many times alerts are not being used on log data, because people get it and they drown, and then they go to the logs and they get like 1,000 exceptions and no one can do anything with that. So this is where we'd like to create very specific alerts with meaningful names that go to specific queries and utilize features that allow us to be laser focused. So let me know if there's an exception in the payment page that happened to more than 100 users in 5 minutes, grouped by city. This is already, and that you send to the marketplace team operations channel. Now, this marketplace team that developed this is going to get an alert saying a lot of users are getting a particular exception in your page. Click that and see it. And then they can really act fast or move it to someone else in the team. Or maybe the description of the alert will say, if it's an SRE team, please contact this team and this is the feature owner. And it all depends on how you run the ownership model in your company. But of course, when you create the right type of alerts that are laser focused, you can achieve a lot more cooperation within the organization and how they handle these alerts. And then they'll start creating their own, because these alerts are much more informative than the metric alerts or even the tracing alerts. So that's in very high level, how I would define a proper alert, very specific, meaningful name, add description. And there are many types of alerts that give you different angles to problems. So I want to quickly show you something. If we go to the log screen in Coralogix, clear out the query, and click Create Alert. So there are a few types. The standard alerts are classic ones. Notify me immediately. If something happens, just notify me that very second. This will go to the critical logs, and it all connects again. You remember the critical logs that if they appear, you stop everything and fix them. This is where you use notify immediately. Then you can also say, notify me only if something happens, and that something should be a specific query. So user failed to send message to seller. Only if this happens more than 100 times in an hour per IP or per user or per host, send me an alert, and also notify me once this is resolved. So that'll be the second type of alert. This is a volume alert. So there's immediate and volume. Another, one of the most proactive alerts that I like is less than alert. This will notify me on fewer logs of a type that I am expecting. Let's say database table cleanup completed. This is as proactive as it gets. If this doesn't happen one time every hour, let me know. And this takes you to the next level of proactivity, because these alerts are the best. You get them and you say, oh, if this continues in 3 days, my database is going to fill up and crash. So I have 3 days to plan my time now and be extremely proactive. Think about the time it'll take you to start seeing that in your matrix. It can take days to get there. So that's another good one. And of course, just to reduce alert fatigue, we offer the more than usual, where we build a model of a dynamic threshold for that, but this is not a must. Ratio alerts, they're very useful to understand the amount or the ratio of actions inside your application that are experiencing an issue. So if this will be user failed, and my user will be user failed to send message to seller. Let's stick to the e-com example. Then my second query would be message sent successfully. And then the query would be something like message and status is 200, or even I can say 200 to 299. And then only, so failure and success, and then notify me if failure divided by success is more than 10% in an hour. So now only if more than 10% of actions are failing, I want to receive an alert. So that'll be another type of alert that is important. And this one allows us cardinality alerts, unique count alerts. So it's okay that a user failed to send a message. That happens. Notify me if this happens to more than 1,000 different users in 30 minutes. So now I know, or even 1,000 different users in 30 minutes from the same country or from the same city. So if it happened to more than 1,000 users in the same 30 minutes in the same city, I want to receive an alert. Or let me know if it happened to a new city that never had this type of error in the past 3 months.
So Ariel, with that type of alert, let's say one error or one error produces 100 different stack traces. Is there a way you could use that to kind of ignore the other 99, if you like?
I would probably, what I would do is to say unique count on, or I would actually say something else. I would use new value and say, let me know if there's a new error message that I haven't seen. Only if there's a new error message that you haven't seen today, only then I want to receive an alert or a new alert on this. Mm-hmm. And of course, I would also like to use time relative. So this happens, I'm new to the system, I'm in USRE, I'm in Knox Center. I don't know how many of these happen. Notify me if they happen more than 150% of the previous or of the same day last week. So these are different types of alerts that give us different perspective on data, and they do not exist for Matrix, and they do not exist for traces. So now I know not only that there's a problem, I also know how many users experience that problem. I also know what's the percentage of users, like these users, how many of them they are out of my total users. I also know if it's a new problem that haven't happened before. And I also know if it happens more than it happened last week. Think about the intel that I'm getting from these alerts that you cannot collect anywhere. This is business value. Now I can come to my manager and say, listen, like 5% of our users are failing to purchase on the website. It already happened to more than 1,000 users that should have paid us over $1,000 for each deal. It happens mostly in London City, and it's new. It never happened there before. And last week, it did not happen at all. This is information that is so much more, accurate and meaningful than, hey, we have a lot of failures in purchasing. I just noticed that. This is next level monitoring, connecting business to monitoring and observability. And this just makes you better at prioritizing, solving, and articulating the level of urgency of a problem, both to the technical units and business.
Let's just think about that for a second. When are you actually trying to do this maths, right? When you're trying to join together, okay, so I've seen this log and I need to go and find out how often it happens, when it happens, and why it happens. In the UK, we have a phrase, sod's law, right? It always happens at the worst possible time. So you're not going to be doing this at 1 p.m. after a coffee. You're going to be doing this at 3 a.m. when everything's broken, it's on fire. You don't want to have to do what is essentially maths at 3 a.m. trying to tie together a load of different stuff. What you want to do is have all that presented to your very, very tired brain, so you can go, hey, I've got all this information, and the leap is much easier, right? So you're investing in your ability to troubleshoot. And it's not a great deal of extra effort to get these things working, right? It's just a bit of forethought and a little bit of design up front, and then it pays dividends over and over again every single time you have an issue.
I agree. But remember, you had to write to go through the different stages to get to this point. Mm-hmm. So you need structured logs, because we group by a key. You need properly define what's error, what's critical, and so on. You needed the metadata to be able to notify, on the city or the user ID or the IP. And you needed to be written in human language that you can read, because I just said, user failed to send message. These things are building blocks that take you towards proper observability and proper alerting, mm-hmm. and better mean time to detect and resolve. And then once you have all that, you want to create the right, we say organizational structure, but it's just the way you build your Slack channels and your PagerDuty and on-call rotation and even responsibility models. So you want to have an organization that says, here are the channels that accept alerts of different services and different types. Here are the people that are responsible to view these channels and take care of alerts once they get there. We trust each other to not spam each other. And here's the ownership model that says, if there's a problem in this service and I don't know how to solve it, this is the responsible feature owner that'll take care of that. And the data has the right labels and metadata to know exactly what's the impact, so how urgent this is, and who's the feature owner that needs to take care of that. So once the on-call rotation is set, now we'll talk about to push or not to push. The channels are structured right. The data is descripted well enough so I can solve problems myself and read it. And in case I can, I know who's the feature owner that'll help me. Everything's streamlined and everything is working in a way that is, doesn't frustrate you like many companies when we look at monitoring and debugging. And then we come to the last question, which is to push or not to push. So do I push an alert to, PagerDuty or even Slack or email or cell phones? There's a nice exercise that I like to do, which says, what would you do if this woke you up in the middle of the night? So there are a few options. When an alert wakes you up in 3 a.m., either you look at the alert and slam your phone and go back to sleep, or you look at the alert, you pause for a second and you say, I need to look at this tomorrow, or you wake up, wash your face, and sit on the computer. These are the only options possible. If the answer is 1, which means you slammed your phone and said, I can't believe I woke up for this, don't define that alert at all. It's just irrelevant. No one's going to look at it ever. It's just creating noise. If the answer is, I look at it, I pause for a second and I say, I have to look at this tomorrow, great. Create the alert, don't push it. Don't send it anywhere. View the dashboard, create a routine. Again, it's about trust and responsibility. Create a routine that someone cleans up the dashboard, looks at all the alerts per team, per service, per feature owner, and then don't push them anywhere. Only if the answer is, I wake up, wash my face, and look at the computer, only then you push the alert to Slack or PagerDuty or cell phone. Because that way you reduce alert fatigue and you really take care of the things that matter. So again, that's the final stage of accepting proper data that is properly labeled, that is readable, and is alerted properly. Now you accept it. You know that it's important if you accepted it. You have all the data in front of you, and you have the focal point in case you can't solve it yourself. This is how you achieve top-level monitoring and uptime. Anything to add there, Chris?
Nothing other than I'm always grateful when someone doesn't wake me up at 3 a.m. So we used to have a, I'm in the UK, so we reward almost everything with alcohol, and we had a fund that I believe it was if an alert woke you up in the middle of the night, somebody owed you money if it wasn't a serious, or somebody owed you a few drinks if it wasn't a serious issue, and that was the greatest motivator. All of a sudden, everyone was super cautious and super thinking about it. So don't do that. That was a bad idea. It encouraged some very bad habits in the team. But definitely think about incentivizing the behavior of be very, very strict and stringent about what makes it into your logs, or what makes it into your sort of actual push events.
I actually agree. It's either the exercise of what happens if I get it, or the drinking game. Both definitely work inside the organization. And I want to talk about a subject that is oftenly missed, which is enhancing logs with CI/CD. Logs are a byproduct of the CI/CD process, but more than that, logs are the one of the biggest benefits that you get into understanding how do you perform CI/CD fast, efficient, and how do you perform CI/CD without compromising quality. So when you log the audit logs, let's say you use Jenkins. So we at Coralogix, we have a Jenkins plugin. You just install it and start sending all the audit logs and matrix and so on. Now you can discover problematic builds, audit things that are changed without the right permissions or the right process, hot threads, the tests that take the longest, how long does it take you to deploy per service. You can understand, if you have scaling issues or errors in your deployments, this means that you can improve the deployment process itself. The ability to release a new version to production within 15 minutes instead of 40 or 50 minutes can sometimes be a huge difference, make a huge difference. If there's a problem on your e-com that no one can pay because, some faulty version went up and it takes you 15 minutes to fix it instead of 45, that can mean millions to a big organization. And that's something that you can achieve so easily and so quickly that it's a shame that it's not oftenly used this way. And all the good CI/CD platforms support it by default. When we look at GitLab, when we look at Jenkins, of course, when we look at Circle CI and others, Heroku pipelines, all of them send the relevant logs, matrix, and labels and tags. So they've already done the homework of how to write proper logs, and they're there. So it's only a matter of installing the plugins, collecting the data, and then enjoying, predefined dashboards and alerts there to make sure that your process of deployment is monitored, audited, and streamlined. Anything there, Chris?
Just that more often than not, what people do is they set up a CI/CD process and then they realize it's very, very slow. And then they go about this kind of tuning process where they They look at build times and things, and these builds are usually a couple of minutes, and deploys usually a couple of minutes. The real slowdown, don't get caught up in the purely technical metrics. Look at the full cycle time of your system, right? I think the Accelerate report in 2017 called the developer mean time, or the developer cycle time, from commit through to production, all the way through the environments. Logs are gold for this. They're super, super useful for this, because metrics will tell you, oh, it took an hour to get from dev to stage. Great. Well, that's really useful. We know nothing else about it. But logs might tell you about why your application took a little while to start up, or maybe the build nodes became unavailable, and that's what slowed things down. And there's a log that regularly says, oh, we were waiting for a build node, and it took 10 minutes to arrive, and then the whole build took a long time. So just invest upfront in this CI/CD process rather than try and chase your tail a little bit on that one. And yeah, just logs are awesome for enhancing your CI/CD. It's one of those things that you say and people kind of go, what? But then when you get into it, you realize it's super, super valuable.
Definitely. And then the last part after you deployed is using the time frame of the version deployments per specific services and environments to understand, the impact. Get a fast feedback loop, understand whether there's a problem, and accelerate the process itself. That means you're faster to market, respond faster, understand, and reduce the stress that comes with every major version deployment. Chris, you were saying?
This was my favorite one because I like this because it really, really inverts a standard thought or standard concepts about deployments, right? What people normally do is they commit their code, they're happy for the automation to take it all the way through, in some cases, all the way through from master to production. You're straightforward, nice and easy. It hits production, and then they go straight back to human mode again, and they start reading dashboards and graphs and logs and scouring for anything that's going wrong. And that is a tense 5 minutes, right? Where you're like, what's broken? Yeah. Is anything broken? I think it's okay, right? So imagine if you can use benchmarking to let it tell you, is anything different? Is anything really weird going on here? Having that extra level of kind of almost heuristic monitoring, where it's just kind of replacing some of that human intuition, is brilliant, because it means you can spend your time either moving on to the next task, which is great, or you can look for very, very refined things and know that this benchmarking will catch the 90%. It's the 80-20 rule, right? 80% of the things will be caught by the benchmark versions, and you can focus on that 20%.
Do that within a minute and not tens of minutes.
Yeah, and there's a whole team doing that, right? That's like an hour, just up in smoke, right. At best.
One of the things that we created there is the version benchmark. So we use our way to cluster the data and learn normal behaviors and all, and everything combines. You see the version tags on the data as you search it, but more than that, when you go to the tags view and just click a tag, you'll get a full benchmark of that tag. So what happened to the error ratio, what happened to newly introduced errors, error volume, and so on. And you can see everything in comparison to the previous version, so you can understand whether something broke, whether there are alerts that happen after the new version that are critical to you, and now we know how to define proper alerts, errors that happen more after your deployment, newly introduced errors that happen after your deployment. So this critical log never happened. Remember that critical logs are something we stop everything and look at. This critical log never happened before your deployment, so it might be related to it. And of course, you can add widgets that compare the previous version to the current graph that you created and look at the top errors in this version. So within seconds, you go from, I don't know anything about this new version, to I kind of know whether this version is good or not, and whether I should roll back or release a patch. I can even export it to a PDF and just share it with my friends in my Slack channel that was dedicated to this particular service. And there's people there that know exactly what to look at if I tell them this new error was created in this version. And if they don't, they already know who's the feature owner that they need to talk to, and they know what alert to create to prevent it next time. So it all comes back to, I repeated that term so many times today, feedback loop and responsibility model. If both are set properly and the data supports them, you get incredible results. And then to the next point is logs to matrix. Often they seem unrelated, but many times logs being so chatty and expensive and heavy, you can store them for a long time. And so you want to create meaningful matrix from them and then store those matrix for a longer term, maybe 90 days, maybe a year, in a very cheap and efficient way. So what you can do is there's roll-up mechanism in Elastic. You can create your own script that will query an API of any logging tool you use and generate matrix from that. What we offer is that you can create matrix without even ever storing the data. So you can basically create a metric that says, take this metric field. Let's imagine that this is the CPU, and add another metric field. Let's imagine that this will be the memory. And now I want you to extract minimum, maximum, sum, count, average, and so on, and label it by the message and event ID and provider name, and maybe also the host name and so on and so forth. So now we generate that labeled matrix, and you remember the combination of matrix and text, and we generate and store it for a very long term, and you can present it in your UI or Kibana or Grafana, or you can pull it and use an API. And that means you use the power and wealth of log data to generate long-term matrix and combine them with your short-term infrastructure or business logic matrix. That gives you full control that connects everything we've learned about log data today with what we already know about matrix and how to use them. And that's already a 360 view. So think about all you know about that alert and that log, how many users it affected, where it happened, whether it's new or not, it's more than last week or not, all the metadata that happened in that time frame, the specific users that suffered from it, the specific size of purchase that we lost, and now combine that with long-term statistics about how your infrastructure looks like or how other business logic API looks like, and correlate them. How does errors in my log data affect my business performance? How does lack of infrastructure leniency, if I'm too lean with my infra, how does that affect user experience, and how does that affect business results long term? These are things that are the holy grail of monitoring for years and are now achievable with some of the new technologies in the market.
I think just to add on to that, being able to hold on to metrics for a very, very long time also reveals these trends that are big, big trends. So for example, in a previous role, we were tracking deploys per day. And we were tracking that as a dead simple metric, and we followed it. So we followed it for a few months, and we found that we thought it was relatively flat. It wasn't until a year that we found it was actually seasonal, right? And that we found out in the wintertime, we actually do fewer deployments. And it was an interesting little experiment where we found out that actually people are more sick more often in the wintertime, especially in the UK, where it's like, it's wet and rainy all the time anyway. So in the winter, it's basically just don't go outside. What we found was it's a super interesting productivity metric, right? Where in the wintertime, it's like we should expect less from our workforce because they're all sick all the time. And it's common sense, but also it's an interesting story that the data tells you. You just have to hold on to it for long enough in a efficient enough way that you're not spending a fortune. So it's just one of those things. Super interesting.
And I agree, by the way. Long-term reveals things that let you make long-term decisions and not only focus on the short-term. I got to, put up this fire. I got to put out this fire. We're saying go to our chat, but I can't do that if you guys stick around for an hour. So why logs are called logs. So if you notice, the speed of boats is measured in knots, not in kilometers per hour or miles per hour. The reason is that in ancient times, what did they do? They took a long rope, they tied knots every 10 meters, let's say. They tie it to a log, and they throw that log to the water, and then they sail. And then they count how many knots had passed through their hand in a certain time frame. And now I have 100 meters in 5 seconds, let's say. And then they write it in a small notebook that says, I sailed at 100 knots speed towards northeast at this angle. And then when you want to know where you are in the middle of the ocean, you just open that log book, you read it, and you point out where exactly you're currently based on the speed and direction that you were sailing. So this captain logbook is what became the log files that we currently use in software.